Well, good evening time, Mr. Steve. This has been a long time in the coming for you. This Golden Falcon has been fun. Steve sent me this little Golden Falcon here, and it's exteriorly in relatively good shape. But when I opened the case, I found at the previous CB shop that had been working on it. I'm just gonna say it. Didn't know what they were doing, and they created a situation inside this thing that was pretty dangerous. So I went in, and the first thing that I made the observation on was this relay was smoked. And I mean smoked. Look at that. And I had some of these little 12-volt old slapper relays like this, but I can't. They got lost in my empire of dirt. Straight up, I just can't find them. So I went ahead and I thought, well, I'm going to tackle this anyhow. And I went in here and I replaced the relay, and they had quite a bit of stuff in here wired not appropriately. There was stuff tied to stuff that shouldn't be. Like the filament voltage, they had it for the driver's section, they had it going through the relay that was here. So I ended up replacing this relay. It was actually orientated like this with a new modern 25 amp relay. The reason it's got to be so high amperage is because every time you key with this Falcon, the plate voltage turns on and off. The about 600-700 volts of plate. It's applied with these 6LF6 tubes. We switch the transformer on and off for the high volt tap. That's just the way they do it. It's to cut for safety, but we got that all rewired. And then I had to wrap my mind around this knob. This knob right here actually controls the drive filament. So here's your driver. And then this knob feeds around and goes to this circuit here. And it feeds the filament voltage for the amp. And this is your low and your high. Well, this is supposed to be a low and high switch. So you get down here and you look, you can see it on the face. There's a low and a high indicator. Somebody has gone in here and removed that and put a variable potentiometer in there. And that center leg that's on that potentiometer comes around, it runs the filament. I'm not a big fan of that, but that's the way it's set up. So the other thing is that they had this choke, and they had it going down here, which is part of the bias circuit for the tube. And instead of having the bias currently set up the way it's supposed to be, they had this ormite in there for some reason. And they also had this hooked to that relay, which once again isn't safe. So I went ahead and I removed the ormite, wired everything the way it should be, fixed up all the bad solder work that was here. They had the wires that make the relay actually work. This is the sense lead down here. It's just a little piece of wire that inducts by another piece of wire, and it picks up enough weep signal to drive this transistor, which allows this relay to fire and this relay to fire in succinct union. This is the one that controls your antenna switch. Okay, so it kicks the, it takes your antenna click, or it takes your radio click, puts it into the amp, takes the antenna click, and hooks it to the output side. So then I got that all worked out, and I come over here, and this was all butchered up. They had this, I guess this was supposed to be a parasitic of some kind, mounted up in here. Not necessary on this tube. I mean, you could put them in there, but it's not going to help you none. And then this blocking capacitor is just done. There's no capacitance in it, so internally this thing has arced across. So I went ahead and I replaced that. And the plate choke was completely missing. I added this. There was no plate choke whatsoever anywhere on that. It was completely gone. There was a solid piece of wire there. So if and when they ever did key it, all the RF was flying right back into the high voltage circuit. Nice, right? So I put the plate choke in it, and then went on to trying to make the band selector work, which this band selector is just here for show. It was never actually hooked up to anything. So let's go down in here and let's take a quick look at the backside of this band selector. If you can see the backside band selector, which the way they have it wired the paddle arm is almost pretty much always hooked up. You wait till Daddy shoots a video, get a drink there, big boy. It's pretty much always hooked up. The problem is this is the wire that runs across and feeds the inputs to all 4 of the final tubes. The paddle that's attached to this band selector is burnt off. Well, since we're only going to run this on 11 meters, or you're only going to run this on 11 meters, Steve, I just went ahead and jumpered it across. So now it's a direct drive. But before I did that, I did tube emulation, and I came in here and I looked at it with my KC901. This is basically like a really fancy MFJ with a whole bunch of other shit attached to it, you guys. And we got the input to the tubes perfect. Now what I do have to do is I got to come back and finish tube emulation on the input side and go in here and play with the input because it's a little off. So okay, then I come to the output side and I had to reattach to the plate, or it'd be the tune, this wire because it was off. And then this distribution bar over here was broken in half, and of course the blocking capacitor here was also toast. So I got all that working, got all that hooked up, and I thought, sweet, I'm finally ready to turn it on. So I click on the turn on switch, and these 4 tubes light up. Well, these 2 tubes light up, and those didn't. And the lights dimmed, so I shut it back off. Actually, I ran the variac back down. So through a process of elimination, the first one was pretty simple. This was in the drive section. This tube is turned into an air bottle. If you can look real close, you can see right here and right here there's cracks in the glass. Now guys, Steve, when he sent me these, he's packaged these separately, which I always strongly suggest everybody does. If you're going to send me a glass tube amp to work on, package the tubes separately. He put them in their own separate containers that were stock. I don't know, this 7,500 numbers written on all of them, but I'm strongly questioning some stuff. We'll circle back around to that, because I don't know where he got these tubes or what the deal is with them, or I don't know. I don't know what happened when they were at the other CB shop. I don't have enough 6LF6s laying here for me to retube this thing. I do now. I'm going to order them. I want to make sure I got enough 6LF6s, 6L. I got a bunch of 6L or 8950s and stuff, but no 6LF6s. Bad me. We'll take care of that. So anyhow, when we turned this one on, the filament turned on. The filament shorted out, and then the getters, which are these coils here, which are designed to burn up. When they produce this tube, there's no vacuum. They produce it, you'd like to think they produce it in this like low oxygen vacuum environment. No, that's not how they do it. They produce the tube, and then by overvolting the filament, they turn the getters on, which are these 2 heating elements, which then in turn burn off. As you can see, this is what a standard getter looks like. They'll burn off all the oxygen and any other molecules that are inside the tube, and which creates vacuum on the inside. So this tube's turned into our air bottle. It's junk, Steve. This one here is shorted, as in like it is, the filament is shorted completely out and is dead bad. Do not put back in the amp. I'm going to send this back with it, Steve. So I took one of the good tubes out and figured out what was going on over here. You have a loose socket. It's on the bottom corner. If you don't have the tube just jacked and the socket is right, the filament won't light. So between this one in the drive section and this in the final section, I figured that out, and we got the whole thing working. Now I dug around in my supply of tubes, and I've got enough 6LF6s. One's a GE, the other one's a Svetlana. That's the reason that they're different sizes back here. We got 2 fully functional 6LF6s for our drive section. So we're going to be able to demonstrate this thing at least working. But what I wanted to show you is right now how we have this set up is so I can look into, through this piece of coax, look through, go in the output connector, go through the relay, go back around to the coax, which is down here, and look at this entire circuit electrically all the way back to the relay and make sure it's resonant. Because I've done that between the driver's section and the final tubes, and now between the final tubes all the way back to the relay. So we're looking at it in reverse. Now I've emulated load, so what I mean by that is you add some special little pixie dust parts that make it think, make the circuitry think, and make the meter think that the tubes are in operation. You can simply go look that data up on the data sheet for about anything. So let me click in the relay here manually by hand. Let me explain to you what we're looking at first, Steve. Over here, I'll look at the little red cursor. So at the bottom end of the band is 23 megahertz, and the top end of the band is 30 megahertz, and this is all the way across the spectrum. And right here in the middle is the Super Bowl, otherwise channel 6. Hold on. What I was doing was putting a piece of paper in the relay. It's going to require 2 hands. So what I'm going to manipulate over here is the plate and the load. So the lower we dip down, the better the resonance the box can be. So if the tube receives the right amount of drive and has all the right shmoo around it, all the high voltage, all the right environment for it to work, hence the circuit for it being resonant, it will produce power. So what we're demonstrating to you here is anywhere in the CB band that we want to operate it, or 10 meter band, just by manipulating the tune and the load, we can bring it into perfect resonance. Either be on 6, or say about channel 20, which would be about there, or about channel 28, which would be right about there. And this is a resistance flow. The lower we go, the less resistance to the RF. And all that simply tells us is that the circuitry attached to the output portion of the tube is correct. Now I'm going to do the same thing with the input portion of the circuit, and we're going to get back to that, and then we're going to fire it up and test it. Now I've already fired this thing up and run it, and I already know what the results are going to be, but let me do some polishing on the input circuitry. I'm going to show that to you as well, and then we'll be back. The long and the short of it though, Steve, is I think you got bamboozled on your tubes. Actually, I know you got bamboozled on your tubes, but I want to show you that everything should work, and if you go just simply purchase brand new tubes, this box will be off to the races and running. So let me go play with the input tune, then we'll get on with the testing of it. Finally figured it out. It's 3:40 in the morning, and I've worked on this for about 5.5 straight hours this evening, just straight, just standing here, because I was really quite confused with what was going on. And I mean, I was very, 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 very confused with what was going on with this box. So the crackhead that had been in here before me, and after 4.5 hours of trying to understand why he had this, I'm sorry, I couldn't leave this alone. I was going to leave this alone. I had it working. It was throwing a really low dead key, but it was surging up in its output power, and it wasn't running right. And I couldn't. So what they had done is they had attached, you'll see that this board's changed a bunch from the last video. There's now a full wave negative bias cutoff circuit and whole 9 yards installed. What they had done is they'd hooked up this potentiometer, and then they took the ground reference for the bias control off the drive tubes and the output tubes and brought them to this knob, and then they created a negative voltage circuit. Well, unfortunately, when the tube goes into operation, the voltage takes way off. So just as a dead key, the voltage would come up, then you modulate forward, and then as soon as you unmodulate it, fall back to 0. Passed all that horse shit. Took all that out. This knob does nothing. You're going to control your dead key with your radio, and you're going to be amazed with 1 watt gets you. Normally, how they would do this is they'd have a secondary relay in there, but this thing, from what I can gather, I went and looked at some pictures on the old inner boob, is quite heavily modified. Quite heavily modified from the stock version, but it's okay. It's working perfectly now. I also went in and I found a couple broken disc capacitors on the back of the tubes because they were giving me the wrong They weren't giving any ground reference to the tube, and so this tube was wildly oscillating on us. So now I was also thinking to myself in the first video that you just had flat tubes. No, it was the crackhead that worked on this thing before had basically the gain structure of the transistors all screwed up. He had to bias, just a complete mess. So he's probably what is at fault for this tube being bad. This one, it's the snare bottle that lost its vacuum. So anywho, we got her in standby at the moment. And we'll show you how much drive I'm going to put into this thing. It's not going to be a lot. So, Steve, when you get it back, you're going to have to buy 2 new tubes. Nah. Let's put this thing into transmit. Let's watch it work. 1 watt. I'm dead keying 1 watt right now. Swing at 800. Audio. Let's turn the sideband delay on. So we're dead keying about 120 watts with 1 watt worth of drive. We're running out to the maximum what the tubes can produce. You're going to hear this thing chatter every once in a while, and what it's from is the RF power gauge on the front of the box. If I want to modulate it just right, this thing chatters. There's nothing I can do about that, man. This thing is all held together with masking tape, and I'm deathly afraid to take it apart. I don't want to damage the meter aesthetically from the outside. It's trying to work. Other than that, man, it's all fixed up. Steve, you're set, bro. I'm going to put the tin on this. I'm going to put the video in the gargler. And I'm going in the house because I'm tired of standing out here working on this. I was hoping to get a whole lot more done today, but Steve, the Golden Falcon 400 is back from the grave. All the crackhead creations in here between the messed up this and the modified band switch here and that being all messed up and the burn up plate choke and totally burned up relay and screwed up bias control and broke disc capacitors and wicked input tune and oh yeah, buy 2 new tubes. That's all you gotta do. All fixed. 100% functional now. Tired. Gentlemen, my name is BBI, and without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. Come follow me on Facebook, Twitter, Snapchat, Instagram, primarily Facebook. Hope to see a lot of you guys at the, what are we, I come along with 14, so we're 17th annual or 16th annual Bakerman Break that's coming up, you guys. And then I will be in Manchester, and then I am going to Hawaii. So, appreciate your all support. Couldn't be here without all you guys. Oh yeah. This amp was built the same year I was born, by the way. 9-17-76 400. I was born 3 months later, but not on that same date. Pretty close, 3 months later. 40-year-old girl. I'll see you guys. Bump.